Okay, so for question number 9, for any set of R and S, probability of R is equal to probability of S prime intersect with R plus probability of S intersect with R. Show that, so we want to show from this equation, probability of S prime given R can be written as 1 minus, oh sorry, this one is no prime. Probability of S given R is equal to 1 minus probability of S prime given R. So how can we relate between these two equations? So we notice that here is in intersection form and here is in the conditional form. So what is the relation between this conditional and intersection? So we know that the conditional formula consists of intersection between the two events, right? So what happen if we change this equation into the conditional? What do we need to do? So for S prime intersect R, to get S prime given R, so we need to divide by probability of R, right? So why not we divide everything here with probability of R? Or we know probability of S given R, the general formula we know for the conditional probability is equal to probability of S intersect with R divided with probability of R. Right? Okay. So, let me write down this again. So, probability of S given R is equal to probability of S intersect with R divided with probability of R. And then from the previous equation given in the question, probability of S intersect with R, this is the equation related to probability of S intersect with R, which is equal to probability of R minus, so if we let it as the subject, so this is equivalent to probability of R minus probability of S prime intersect with R. So all divided with probability of R. So what do we have? This one, probability of R divided with probability of R is equal to 1. And probability of S prime intersect with R divided with probability of R is equal to what? Yeah, this is equivalent to probability of S prime given R. So now we have shown that probability of S given R can be written equal to 1 minus probability of S prime given R. So this is one of the method we can show the equation, this equation. Or another method, we can just directly divide everything with probability of R. So we get 1 here, we get probability of S prime given R and probability of S given R. So rearrange so that probability of S given R as the subject. So we have the same equation. We have shown everything the same. Okay, that's for question A. How about question B? Okay, now for question B, it's given that probability of R is equal to 0.5 and probability of S prime is equal to 0.3. And also it given that probability of S prime given R equal to 0.5. The question asks you to find probability of R union with S. So what is the relationship with the unions? So usually for union, we will use the formula of probability of R plus probability of S and minus the probability of R intersect with S. So we have the R, we have the S, we can find it from the complement, and then we don't have the probability of R intersect of S. But what do we have here? We have the probability of S prime given R equal to 0.4. So what is the relationship between the intersection with the probability of S prime given R? So we know from this equation above that we have shown probability of S given R equal to 1 minus probability of S prime given R. And that probability of S given R is equal to probability of S intersect R divided with probability of R. So what we have 1 minus S prime given R. This value is given, which is equal to 0.4. And also this probability of R is given, which is equal to equal to 0.5. Now we can find what is our probability of S intersect with R. So if we see here, S intersect with R is equal to, this one is 0.6. And 0.6 multiplied with 0.5 is 0.3. So we have the intersection probability of S intersect with R equal to 0.3. Now to find the probability of R union with S, or S union with R, is equal to probability of R, which is 0.5, plus probability of S, which is equal to 1 minus 0.3, which is 0.7, minus the intersection, which is 0.3. So we have the answer here is equal to 0.5, 0.9. Okay.